So class, today we are going to learn this factor, that effect of catalyst. We have done that factors affecting rate constant. Out of that we have done first concentration. Concentration is not like that much important topic, because we know that if we increase the rate, if we increase the concentration, rate of reaction will also increase, and hence the rate constant also increases because of this that relation. Yes. Okay, so if this one will increase, if the concentration of reactant is increasing, that means rate of reaction is also increasing, rate constant is also increasing. And second factor we have done yesterday class, that is temperature. Okay, how it increases, how what is the change in that. And now the third factor is catalyst. So first we should before knowing this effect, we should know the catalyst. What is the catalyst? Catalyst is a substance which alters the rate of reaction. Got it? Why I'm writing alter the rate of reaction? It can it can increase as well as decrease. In that surface part, you have done two type of catalyst. One is promoter and another is inhibitor. Okay. So basically, the catalyst word is used for promoter, not for inhibitor. Okay. For the either you write catalyst or you write promoter, it means that it is going to increase the rate of reaction, but the one which will decrease the reaction will be specifically known as inhibitor. Got it? Okay. And the most important thing is that without undergoing any permanent change in itself. That means it doesn't change itself. Okay. So how it changes? If we plot a graph between this potential energy and the reaction coordinate, so it is seen that it is observed that suppose that this is reactant and the product. So this is the path by which the reactant is going to convert into product, and it is assumed that the catalyst gives an alternative way to convert it into the product, to convert itself into the to convert the reactant into the product. Got it? It gives the alternative path. Like if we use the catalyst, it will go like this. Okay. So what happened? It changes its path. It gives the alternate path by which we can the reactant can easily convert into the product. And what basically it is doing, if we check, this is the activation energy. Yes, this will be the activation energy for the reaction without using the catalyst, isn't it? This one is showing without catalyst. Okay. And if we use the catalyst, this activation energy is going to be decreased, isn't it? It is like this. So basically, what does this catalyst do? Catalyst decreases the activation energy, and hence it increases the rate of reaction. Okay. So this is the path without with catalyst. Yes, we can write with catalyst. So according to the Arrhenius equation also, we know that if lesser the activation energy, faster will be the rate of reaction, isn't it? So similarly, this catalyst, what it does do, it decreases the activation energy. So I can write actually the catalyst decreases the activation energy, and hence it increases the rate of reaction. Okay. So, or you can say that the catalyst, how it is increasing the rate of reaction? By decreasing the activation energy. Got it? Like this. So this is the thing you have to know. One very important thing you have to keep in your mind, that catalyst doesn't change, gives free energy. Okay, gives free energy, and the equilibrium constant that doesn't change by catalyst. No effect of catalyst. Okay, got it? Done with that? So this is the thing you have to know. And how it is changing, how can you say this is equilibrium constant? Because this is kf upon kb. So equilibrium ka matlab kf and kb will be equal. So it is doing the same way. for the forward reaction as well as for the backward reaction. Got it? So this is the thing. So this is the effect of catalyst. Hope it is clear. Any doubt? So okay, after this there is a theory, that is collision theory of chemical reaction, that we have to study, and this is the last topic of this chapter. So in this collision theory, Arrhenius, according to it is applicable for wide range, but it says that all the molecules which are colliding with each other doesn't convert into the product. Okay, it is said that suppose that if there is a point and the dart game we are playing, and I said to dart in the center only, so maybe कि आप उसे फेंक रहे हो and that is coming out of the circle, so it is colliding with that board, but it is not colliding the region where that I said, that means where it will convert into the product. So similarly, every collision will not result in the product. So suppose that if I say to this is the tip and this is the tip, if I say that put this tip to, and then only put this, let the this tip collide with each other, and each perfect collision will result into the product. So it is not possible that each time this tip and this tip is going to collide, isn't it? So similarly in this we can say, so for this it is said that it depends upon the what we say, effective collision. And what is this effective collision? The number of collision per second per unit volume of the reaction which is going to convert into the product, that is called collision, that is called effective collision, and it depends upon the collision frequency. So let me write the definition of the collision frequency first, and then I will discuss the next thing. So here I have written the definition: collision frequency. It is the number of collision per second per unit volume of the reaction mixture is known as collision frequency. Okay, and denoted by Z. Effective collision, as I told you, I have used frequently. This is collision, effective collision. What is this? Number of collisions, or we can say that the number of collision in which the reactant molecules collide with each other with a sufficient energy, with the we can say that the required energy, or we can say that the threshold energy to result in the product formation. To result in the product formation is known as effective collision. Got it? So this is the effective collision. If we take an example like A plus B change into product, the rate of reaction will be written like this. Here this and this ZAB is collision frequency. If we relate with the Arrhenius equation, this equation with the Arrhenius equation, we get that on comparing with Arrhenius equation, we get that it is what? ZAB is equal to the frequency factor, isn't it? So this is the thing. Now one more thing, like in class 12th only, in organic, you have done the SN2 mechanism, isn't it? So in that SN2 mechanism, we know that the nucleophile reacts from the back. Okay, as for example, like let me take an example, like this is an example, like, and aqueous KOH, if it reacts, okay, so we were checking that it was going from the back side, isn't it? And it was forming like this, H, and H, and here it was OH. So it was showing the SN2 mechanism we have done. So what will happen if in this reaction only, if suppose that there are the two step, let me write the two step for this, two ways for this. Like one is this, OH minus is going to react, and this is going from the front, this is reacting from the front. So will there be any reaction? No, because it is also nucleophile, this is also nucleophile, they will repel each other and there will be no reaction. But if this reaction occurs in this way, Br, and this OH minus is going to attack from the back, then this reaction will be possible and it will result in this formation. Yes, got it? So this is showing SN2 method. So similarly, this is called a proper orientation. Are you getting it? This is called proper orientation. If orientation will not be there and all the things are there, like all the things that catalyst is there, activation energy is low, everything, collision is there, but if proper orientation is not there, that there will be no reaction, isn't it? So to make a reaction, to make a product, the proper orientation and the activation energy and the proper orientation must be there. Both should be there. So since a new word come here, that the orientation, for this the rate of reaction can also be written as PZAB E upon RT. Where is this? P, what is the P? P is called the probability of steric factor, or that the steric factor, we can say that the effective collision. So, or orientation we can say. So probability of steric factor. Okay. Or you can say that the proper orientation. So this is the equation, we can say. So to make the proper product, we can write here product fastly or easily, or to change the rate of reaction. Proper orientation along with low activation energy, proper orientation is also needed. Is also required. Got it? Yes. So this is the thing. Now this kinetic theory of collision is also having many drawbacks, few drawbacks that we will do in the higher classes. Here there is nothing to, we don't have to go in deep. So this much is for class 12th. Okay, and here is your chapter is finished. Hope you all got it. If there is any doubt, you can ask. Thank you, class.